Okay, so I want to do a full breakdown video of my homemade 18-inch drop saw, lapidary rock saw. Going to go over some of the features, some of the things I wish I'd have built a little bit different, what I do like, what I don't like. So let's start off back here with the big beefy motor. I have a 3 horsepower, 220 volt lapidary motor. Or not necessarily for lapidary, but it's sold from Highland Park Lapidary specifically for meant for continuous running and stuff. So it's really good for these rock saws. I originally had a 3/4 horsepower motor on it. It was enough to spin this 18-inch blade just fine, but it would bog down too easily. So I ended up having to spend the money. I think it was about $500 or so for that 3 horsepower motor. So I've got a pulley down here. I can't remember what size, 2.5 inch, maybe 2 inch. Comes down here to, I don't know, maybe a 6-inch wheel. Again, I can't remember, but your geometry might be a little bit different depending on the RPM. I think I worked it out to the RPM being around 980, which is what I was recommended to do here. So it's a pretty simple design. Let's see if I can do this with one hand here. Okay, so this framework that I have this on was actually from the lathe that I borrowed the motor from. But then I had to replace the motor. But anyways, this whole bar setup thing was originally from a wood lathe, okay? So I just repurposed that way because I can't weld. I don't have any of the tools for that. So you can see I put these pillow block bearings here. I put pillow block bearings on the back. That goes through that 3/4 inch stainless steel all thread. And then I've got a crank over here so I can just slide the whole carriage so that I can make chops on my rocks here, okay? So pretty simple design, just goes up and down. You just have to do it by hand. Getting the balance just right is also pretty important. But I've got these different bolts bolted into the bottom here. And later on I'll try and look up underneath of there. So I can show you how it's mounted from underneath. Basically, there's just a couple nuts holding it on from underneath. But then with these big 3/4 inch wing nuts, I can tighten those rubber straps down. And you can see I've also got a couple pieces of wood that I can use also. And I've got quite a few pieces of that around so that I can do any combination of cuts that I want. Pretty much any rock I can hold in that vise without too much of a problem. Having a set on either side of where this blade goes, you can see that hole that slot I have in the middle there, is really good for large round rocks like the oversized thunder eggs and the big geodes that are just too awkward to hold in a traditional clamp. This works really well for the large thunder eggs and geodes. Okay, so let me set this back down. I've just got it propped up on that brace there. Let's see. The arbor that I used is also from that wood lathe. If you were going any bigger, or if I was building this from scratch, I might go with a little bit larger. You can see that spindle on the end here is only about 1/2 inch. The main portion of the arbor is 1 inch, I think, but then it has a 5/8 inch underneath that thread right there. Under that bolt is a 5/8 arbor size. I would probably recommend going with a 1 inch, especially if you're going with a bigger blade. Which you can see from this design, I could have gone with a bigger blade, but the bigger blades kind of get a little pricey. 18-inch blade is still affordable and was big enough to do the cuts that I was wanting to do. As far as this piece here, this screw here was originally meant to twist up and down, or just round and round, go up and down so that I could slowly make those cuts. But it didn't really work very well. It was a little bit wobbly. You can see if I shake it, there's a little bit of play here. It's pretty solid, but obviously since this was turning when I was cranking it, it was kind of shifting my blade back and forth a little bit, and I didn't really like that. So I ended up just having to do this by hand. Sorry, I'm trying to do this with only one hand here. So when I have this down here like this, I just kind of use this. You can see I stopped the plexiglass, and the oil really doesn't spray over here. You can see I've got these couple of splash guards. The oil really doesn't spray out of here too bad. There's that other shield that I usually have on the front here to catch more of that oil splatter. So there's really just a little bit of a gap here, and I can use this to put the blade up and down. Doesn't usually slip like that. I'm just, that's bad for a demo. Anyways, I can also have it from the other side. There we go. So I can work it from either side. And doing it like this doesn't really make that blade go back and forth too bad, you know, side to side play. It's pretty solid. I don't usually have it sitting all the way down in the tray, so it's kind of bending. This is a masonry tray, a concrete mixing tray, these black pieces. That was originally going to be my catch tray down here, but it didn't really work out the way that I wanted, so I ended up just kind of chopping those up and putting them in here as more splash guard, so that oil's a little bit more contained. You can see I've got one towards the back and one on the side here. So it really catches, that's what catches the majority of the oil spray. These extra little plexiglass sides that I kind of installed after as an afterthought, those do catch some of the mist, but the bulk of the oil is being contained just by these concrete tubs. So if I was going to rebuild this, I would definitely redesign my containment. This was originally going to be just a water-based saw because I didn't want to have to deal with the mess of oil, but it was not cutting well at all. I could not get this thing to cut properly. I had to switch it over to oil, which is messy. I don't like it, but these blades just don't run as well with water. It can be done, but that blade was glazing like crazy, so maybe a different blade, but probably I probably would just recommend sticking with oil, as much of a pain as it is. So I had a smaller, just like a fountain pump that worked really well for the water, but with oil, it was way too thick. So I got this oil transfer pump. I have to say it is way, way overkill. It's gonna pump way too much oil. So I had to put on this valve here so that I could slow the stream, slow the flow of the oil down. And kind of throttle that down a little bit. So I would definitely get a better, not a better pump, but definitely a different one. This thing is just way overpowered. But it's only, I think it was like $90 off Amazon. It does run off of 110. I know that you can get 12-volt ones, but then I'd have to either rewire it or go with battery power. I don't want to do that either. So I got this one that is just ridiculously oversized. So you can see my plumbing here. It's going to pick up, this is just a catch bucket that I have here. I put the oil bucket straight underneath all of this. The oil gets drawn up from here. Also, this motor was supposed to be self-priming, and it worked for the first time or two, but then after that, the oil only gets sucked up to here. So then I have to take this thing, I have to bend it up so that oil gets all the way up into this pump, and then it'll start pumping through just fine. So that's not ideal either. So make sure that you get a self-priming pump. Anyways, so that oil is going to travel through here. It's going to run alongside the motor, goes up here. I have it split off so that it feeds from both sides of the saw blade. Let's see. Okay, you can't really get a good angle. Anyways, there's the oil feed from the other side, so there it is, just from both sides. So you're getting oil down there from both sides, but I am going to redesign that again so that I have a little bit more control over where the oil goes. So I've got several of these that I'm going to get plumbed up in here, and then I can direct the oil to a more specific spot, and I can just, these things are flexible, right? So that way I can put that oil exactly on the contact of the rock. Because one thing that I learned was if I had too much oil flowing, the blade wasn't cutting well. And if I have too little, obviously that's not good either. So getting that oil exactly where you want it is going to be more important rather than just flowing tons and tons of oil down onto your rock there. Okay, it was just way too much. So getting that directed is going to be kind of important. As far as this here, this was just some extra scrap metal. This was actually some shelving that I was able to just cut and screw. So that's not super beautiful either. If you were better at fabricating than I am, this could look a lot nicer. So here's that all thread. So it's got a crank here, so I can just crank this and then move the whole carriage side to side so I can make multiple cuts without having to reposition my rock every time. Okay, because putting rocks in and out of the clamp, I mean, it's not super hard. It's just kind of time consuming and a little bit annoying. So this way, at least you can make several cuts without having to reposition your rock. Okay. As far as back here to help your weight balance, I did find that if I just grab a stick and I hang a bucket of rocks off of this, then I can just move that bucket up and down this stick to help better balance this heavy arm. Okay, so that's kind of important too. Trying to get this balance. I was just guessworking everything, and when I had the smaller motor, it was balanced pretty well. But then when I upgraded to this ridiculously huge motor that I think it weighs close to 100 pounds, it threw my balance off, and I didn't really want to mess with repositioning that arm. So that wasn't super well thought out either. But anyways, if you just put some weight on the back end here, it's all about leverage. So the further you put that out, the more it's going to pull on this end and have less weight on that end there. As it sits right now, as it is, I want to say there's probably about 10 pounds worth of weight pushing down, okay, which is a little bit too much. So it usually kind of wants to bog down if you've got about 10 pounds or so downward force. Okay, so you're going to want to get that balanced out a little better. Putting some rocks on the end, I can get it dialed in to where I can pretty much just let this saw run without me having to hold it every minute of the day. Okay, too light of touch doesn't work well. Too heavy touch on that blade doesn't work well. You really have to get that dialed in. So having that adjustable is actually pretty helpful. Now, all of that oil, you can see I've got some holes cut in the bottom. They're just holes drilled into the base. Okay, there's some of those holes back there where the oil runs down, and then it goes down into my catch pan here. This catch pan is blocked up. That's definitely something I would redesign. I had to put some wedges under there so that it all drained towards the back. Here's my catch pan. It is movable. It does come in and out of there. Of course, since I have it plumbed in the back, it can only come out through the back side. But it's going to catch a little bit of the sludge. Okay, before it goes down into your oil, it's certainly not going to catch all of it, but it's going to catch a lot of that sludge. See if I can get an underneath side here. Sorry, I know I'm going all different angles. There's those bolts from the top side where I have them just screwed into the bottom there, and that holds all those threads in place for my rock clamps. So all that oil just drains down into this pan. I've got a shut-off valve here so that it's not leaking and making a huge mess. This is just a catch bucket. It all just, when I have the oil bucket here, obviously it all just flows into the oil and then gets picked up again by the pump. This saw is a little bit tall. I originally did not have those wheels. I had some big wheels on the back here. And I had some handles up on the front so that I could pick it up like a wheelbarrow and roll it around, but that was kind of cumbersome. It didn't really work super well. So I replaced it with these big heavy caster wheels, which raised it up a couple more inches. So it does sit a little bit high up. I should probably chop that down to size one of these days, but honestly, I'm probably not going to mess with it. Anyways, let's see. I think that's about it. If you're doing all of this out of wood, make sure that you seal everything real well. Give it a good coat of paint so that the oil's not soaking into that raw plywood. This is pressure treated, but actually all this was pressure treated because that's what I had. But yeah, just make sure that you seal everything up real well so that you don't have any leaking joints. You can see oil's already soaking into this because it wasn't covered in paint. Not a big deal, but makes things a little bit messy. I think that's about everything. This is a pretty long video. I guess I'll put it up on YouTube, and then that way when people ask about it, I can just give them the link to this longer format video. If you have any questions, drop them in the comments. I'll do my best to answer. If I did a 2.0 version, there would definitely be a lot of modifications here. You can see this is a little bit janky, but you know what? It works. I think even with the motor, I think I'm under $1,000, maybe $1,200. You know, once I had to spend another $100 on that pump, and all the plumbing. I mean, all the little odds and ends got kind of expensive, right? So you've got pillow block bearings there. You've got pillow block bearings in the back. Pillow block bearings here holding everything in place, right? So all that stuff adds up to be kind of expensive. So I think all in build, it's probably somewhere between $1,000 to $1,200 with all the parts. Labor took me ages and ages and ages to get this thing built because it was just troubleshooting every step of the way. There was another problem that came up, right? And I'm still chasing down some problems. You know, my oil flow system. I just kind of siliconed that in. I don't think I can get the angle. It just goes through the wall there, and then just kind of comes down that saw blade. Not the most well designed, but you know what? I'm just a backyard engineer. So this at some point got pushed up against the pulley and kind of warped that a little bit. So that should be designed better. Whatever, it works. All in all, I'm pretty happy with it. This was a part from the lathe, so it's just giving a little bit more stability. The most important thing though, this is threaded. So this is how I'm getting that back and forth motion because of this block right here. And this is from a wood lathe. I don't know how I would do it otherwise. I don't really know. I just happen to have that from the wood lathe that I scavenged most of my building block parts from, right? So I don't really know what you would do in place of that. I guess some big heavy nuts secured on either side would help that thread go through there. So of course I don't have this pillow block bearing tightened down because this rod needs to slide back and forth. Okay, so it's not tightened here. It is tightened here so that it keeps the carriage in place. You can see that bearing is turning along with the threads. Okay, so that keeps all of this together, and the whole thing slides back and forth because of these threads here, right? So that's how that moves back and forth. It's a pretty slick system. I mean, I do like, for the most part, I'm happy with how it turned out. It's gonna knock my block out, but when I'm doing a blade change or something, it's hard to do with one hand. I can tilt this thing all the way up. Oh, man, okay. I can tilt it all the way up so I can do a blade change. I can do maintenance on it. And this thing's just straight up in the air like that. So that's why I have this extra block of wood. That was obviously after I painted everything so that I didn't get any paint on it. But that's okay. It all works. So again, I would make the drainage on this pan a little bit better. I have to put wedges under there so that it drains all the oil towards the back. Otherwise, my 5 gallons of oil is just going to sit in this thing. Maybe not 5, but I wanted it to drain a little bit more. So I just put wedges underneath of it so that all the oil runs towards this back corner. So it's got proper drainage. I don't know. I can't really think of anything else. Let me know if you have any questions. Let's add one more thing that I didn't quite go over. One here's that extra catch tray, catch piece of PVC in the front there to catch more of that oil. As far as my this piece in the back here, that also catches a tremendous amount of oil. That was actually a pretty crucial piece, and that I just kind of cut a few notches in a channel that I had laying around. So that catches a lot of oil though. So again, I think, like I said, about $1,200 all-in costs, and that is going to vary pretty widely on the scrap stuff that you have laying around. If you had to buy everything from scratch, I don't know, probably tack another couple $100 onto it. But I was able to salvage quite a bit. You know, this metal was just some shelving from something I didn't need. Actually, I have another one. It was just a piece of shelving. I cut that down and kind of made up a janky little thing, but you know, it works. So your price is going to depend on the parts you have laying around. Honestly, if you can pick up another wood lathe, I think I spent $75. I was going to originally actually use it for woodworking, but the shop ends up having this one here, so I didn't really need mine. So I cannibalized it for this project, right? So I think that's about it. Thanks. One more thing to add, if you are going with a larger blade, this 3/4 horse motor still gets bogged down even with the 18-inch blade if I get too much pressure put on it, which I mean, that should be obvious. If I had any bigger of a blade, just because of how this saw is designed, if you had a bigger blade, you'd probably want to go with Highland Park's 5 horsepower motor. So that's going to be even bigger and heavier than this one. This is an 18-inch slab saw, and I think it only has a 1 horsepower motor. But just because of the way this saw works, you can use a much smaller motor. Okay, even though they use the same size blade, the way this one works, that's why I had to go with the 3/4 or the 3 horsepower motor, because of the way these saws work differently. Okay, so same size blade, 1 horsepower motor, 3 horsepower motor, and if you were going with a bigger blade, you'd certainly want the bigger motor, because this thing's going to bog down and just not have enough power to get it through, just because of the design here. Now that being said, I can cut larger rocks in the drop saw than I can in the slab saw because of the geometry, because of the way the clamp works. In fact, I can show you here, because I have a rock still loaded up in there. This big old piece of septarian, I had to make the first 2 cuts on it in this saw. And I have to say, it's pretty slow cutting through this thing, because you're feeding it's not like a nice steady movement like this saw is. This one, it takes longer, or it seems like it does. Of course, I'm cutting through some pretty hard stuff usually. The septarian's not super hard, but a lot of times I'm cutting through agates or quartz or whatever, and it takes a long time. It takes several hours to get through a big chunk of quartz, whereas this is just a nice, steady, even feed that goes into there. But I can't fit as big of rocks, even though it's the same size blade. I can't fit as big of rocks into this as I can with this. Okay, I've got a little bit more clearance on the blade. The vise, just sits differently in this. So bigger rocks get cut down in this first, and then they go into this one. I'm going to get more precise cuts out of this. This saw, the drop saw, the cuts are not as precise. Okay, I will say the real actual saw, surprise, surprise, cuts a lot better. Cuts a lot more smoothly. The cuts are going to come out a lot cleaner from a real rock saw than from one that you built. Now, I got this thing trued in pretty good, so there's no blade wobble, but just the little bit of back and forth motion that the drop arm gives, doesn't make for the world's cleanest cut. It's passably clean, but it's not going to be as clean of a cut as a proper real rock saw from an actual lapidary company. But you're also saving a lot of money. This thing brand new, a couple $1,000s. This thing I built for around $1,000. If you had extra parts laying around, it'd cost you even less, right? I picked this thing up used for $1,500. If I'd have known about this, I'd have just gotten this saw and never even messed with this. But like I said, I can get a little bit bigger of rocks out of this one than what I can out of this, even though it's, like I said, same size blade. So, advantages, disadvantages to both. $1,500 for this is way better of a deal than trying to build this ridiculous thing, okay? Now, again, if you wanted a bigger one, a bigger blade, this is definitely going to save you. Man, the rock saws just get so expensive with the slab saws, you know, the 24-inch and stuff. You know, that's going to set you back, what, $5,000 brand new, maybe even more, I'm not sure. Whereas scaling up on this would not cost that much more. Okay, so you could get a bigger blade for not that much more rather than an actual slab saw. Okay, you could get a 24-inch blade out of this. It's going to cost you a couple $100 more. Bigger, you know, 5 horsepower motor on the back. Blade's a little more expensive. But all in all, that's really about the only thing you'd have to do differently. And it's not going to cost you that much more. Slab saws are expensive, but they're built better. Okay, it's built way better than my homemade thing. Okay.